Right now, as you read this, something extraordinary is happening inside your body. Not in a hospital, not in a lab. Inside you, trillions of cells are making quiet, invisible decisions, whether to survive, whether to repair, or whether to silently dismantle themselves piece by piece. Most people will never know this is happening, but once you understand it, you'll never look at hunger the same way again. This hidden process is called autophagy, from the Greek, auto meaning self, and phagon meaning to eat, self-eating. It sounds disturbing at first, but what it actually represents is one of the most sophisticated survival mechanisms ever discovered in the history of biology. Not destruction, renewal. A cellular intelligence so elegant, so precise, that when scientists finally understood what it was doing, it changed the entire field of longevity research overnight. Picture millions of microscopic cleanup crews moving through every cell in your body simultaneously. They're identifying damaged proteins, worn-out organelles, broken molecular machinery, and instead of letting that cellular junk pile up, they're breaking it down, recycling the raw materials, and using those same building blocks to create something new, something stronger. Your body isn't just surviving, it's renovating itself from the inside out, every single day, without you ever asking it to. Right now.
For most of modern medicine's history, this process was completely overlooked. Cells seemed to function well enough. The cleanup work happened quietly in the background, and no one paid much attention. Until they noticed what happened when autophagy stopped working. Alzheimer's disease, Parkinson's, cancer, accelerated aging, metabolic collapse. The connection was undeniable. When the cellular cleanup system failed, the body began to fall apart in ways that looked terrifyingly familiar. Suddenly, autophagy wasn't just interesting, it was essential. But here's what makes this story truly remarkable. What if you didn't have to wait for disease to understand the importance of cellular repair? What if there was a way, a simple, ancient, zero-cost way, to deliberately switch this system on, to tell your body, right now, start cleaning, start rebuilding, prioritize repair over everything else? That trigger exists, and it's been hiding in plain sight for thousands of years. It's fasting, the deliberate, strategic absence of food. And the question that has consumed researchers, biohackers, longevity scientists, and curious minds around the world is this: how long do you actually have to fast before autophagy wakes up? The answer is more nuanced than most people expect, and the science behind it is genuinely one of the most fascinating stories in modern biology.
To understand why fasting triggers autophagy, you first have to understand what your body is doing when you're constantly fed. Every time you eat, your blood sugar rises. Insulin spikes. Your cells receive a clear signal. Nutrients are abundant, energy is available, now is the time to grow, replicate, and build. In this fed state, your body is in expansion mode. It's not concerned with cleaning up the old, it's focused entirely on building the new. And the cleanup crew? They're essentially told to stand down. This makes perfect evolutionary sense. When food is available, you capitalize on it. You store energy. You grow. You prepare. But evolution also anticipated the opposite scenario, long stretches without food, and it built a response for that too. When nutrients disappear, a completely different set of priorities takes over. Instead of growth, your body shifts into conservation and repair mode, and that shift is where autophagy lives.
The man who helped the world understand this was a Japanese cell biologist named Yoshinori Ohsumi. Working in the early 1990s, Ohsumi began studying yeast cells under nutrient deprivation. What he observed was something no one had clearly documented before. When the yeast were starved, tiny membrane-bound sacs began forming inside the cells. These sacs, called autophagosomes, were literally engulfing cellular debris, old proteins, damaged organelles, anything the cell deemed unnecessary and consuming them. The cell was eating itself, not dying, surviving smarter. Osumi's discovery was so significant, so foundational, that in 2016 he was awarded the Nobel Prize in Physiology or Medicine. His work didn't just explain a biological curiosity, it opened a door into understanding aging, disease, and the very mechanics of cellular life. And when researchers turned to human cells, they found the same system, same process, same elegance. The implications were staggering. If you could control nutrient availability, you could control how efficiently your cells repaired themselves. Fasting wasn't just a religious or cultural ritual anymore. It was a biological strategy with measurable, reproducible, scientifically verified effects.
But timing matters enormously, because autophagy doesn't switch on the moment you skip a meal. The body doesn't enter repair mode just because you passed on breakfast. There's a sequence of metabolic events that has to unfold first, a gradual transition that takes hours. And understanding that sequence is what separates smart fasting from random food restriction. In the first several hours after your last meal, your body is still operating normally. Blood glucose is being drawn from your bloodstream. Your liver is releasing glycogen, stored sugar, to keep your brain and muscles fueled. Insulin remains present. The cellular signals still say, nutrients are here, no need to change course. You might feel completely fine during this window, maybe even energized. But underneath the surface, nothing significant has shifted yet. Your cells are still in growth mode. The cleanup machinery is idle.
As hours continue to pass, something quiet begins. Your liver's glycogen stores start to thin. Insulin levels drop noticeably. Your body begins shifting its primary energy source away from sugar and toward fat. Hormones like norepinephrine rise to keep you mentally alert and physically functional. Growth hormone begins to increase subtly, not dramatically yet, but the signal is there. A message to preserve muscle tissue and protect lean mass while the metabolic transition continues. At this point, you're approaching the edge of a threshold. Your body is sensing the scarcity. The molecular sensors that monitor cellular energy status, proteins called AMPK and sirtuins, are beginning to detect that nutrient levels are falling. They're preparing to send a new set of instructions. But the cleanup crews haven't officially started yet. They're warming up, stretching, getting ready. Somewhere beyond the 12-hour mark, and this varies depending on your metabolic health, your diet in the days prior, and your physical activity, the first real whispers of autophagy begin to emerge. The AMPK sensors formally activate. Another powerful pathway, mTOR, which normally drives cellular growth, gets suppressed. When mTOR goes quiet, autophagy gets loud. It's as if the factory floor clears out the construction crews and calls in the maintenance team. Your cells stop prioritizing expansion and start prioritizing integrity.
This is a profound shift. And yet at 12 hours, autophagy is barely beginning. It's a murmur, not a roar. The real transformation comes later. By the time you cross the 16-hour mark, the process has moved from whisper to work. Autophagosomes, those same membrane sacs Osumi observed in yeast, are actively forming throughout your cells. They're identifying targets, misfolded proteins that could cause cellular dysfunction, damaged mitochondria that are generating more harmful free radicals than useful energy, molecular debris that has been accumulating silently over time. These targets get engulfed, broken down, and their components get recycled into new, functional molecules. Your cells are literally rebuilding themselves, using their own waste as raw material. People who have fasted through this window often describe something unexpected, a mental clarity, a quietness of mind that feels almost counterintuitive given that no food has been consumed. This isn't coincidence or placebo. Fasting at this stage increases levels of BDNF, brain-derived neurotrophic factor, a protein that supports the growth and survival of neurons, enhances learning and memory, and protects the brain against stress and damage. Your brain, in a very real biological sense, begins to operate more efficiently when the rest of your body is in repair mode. It's an elegant design. When you're not hunting food, your brain gets sharper to help you find it.
The 24-hour mark represents a significant milestone. By now, glycogen stores are essentially depleted. Fat metabolism is dominant. Insulin is at some of its lowest levels in the entire fasting window, and autophagy has deepened considerably. But perhaps most remarkable is what's happening to your mitochondria, the energy-producing organelles inside your cells. At this stage, the body begins a specialized form of autophagy called mitophagy, targeting damaged, dysfunctional mitochondria specifically. This matters enormously. Mitochondrial dysfunction is one of the central mechanisms behind aging and age-related disease. When your mitochondria stop working efficiently, every cell in your body suffers. Mitophagy cleans out the broken ones, recycles their components, and signals the cell to generate fresh, healthy mitochondria in their place. You're not just cleaning, you're upgrading your cellular power plants. Research also suggests that around the 24-hour window, the immune system begins its own form of renewal. Old, worn-out white blood cells, the foot soldiers of your immune defense, begin to be cleared out. The body, sensing the metabolic stress of fasting, responds by stimulating the production of new immune cells. It's a remarkable regenerative response, almost like your body uses the temporary absence of food as an opportunity to audit its own defenses and replace what's outdated.
Now, here's where fasting becomes something genuinely extraordinary. As you move deeper into what some researchers describe as the most intense phase of the process, autophagy reaches what can be called its peak efficiency window. The cellular recycling machinery is running at full capacity. Damaged organelles are being dismantled at an accelerating rate. Faulty proteins, toxic aggregates, molecular clutter that has built up over months or even years, all of it is being processed and cleared. Growth hormone, which has been rising throughout the fast, can reach levels significantly higher than baseline, preserving lean muscle mass and actively promoting fat metabolism. The combination of peak autophagy, elevated growth hormone, and suppressed insulin creates a biological environment that scientists associate with some of the most powerful longevity benefits ever studied in fasting research: improved brain function, reduced inflammation, enhanced immune resilience, potential protection against the cellular damage that underlies cancer development. This is the stage that makes extended fasting genuinely compelling from a scientific standpoint. Not for weight loss, for cellular renovation.
But every powerful tool has a limit, and fasting is no different. There's a point, and it comes at different times for different people, depending on body composition, hydration, electrolyte balance, and prior fasting experience, where the balance tips, where the body stops selective recycling and starts indiscriminate breakdown, where the message shifts from repair to panic. Cortisol rises sharply, hunger hormones surge. The body begins catabolizing muscle protein not as a last resort, but as a primary fuel source. Mental clarity disappears, replaced by fatigue, irritability, and a cognitive fog that signals real physiological stress. What was once a tool for renewal becomes a source of harm. This is the critical distinction that separates intelligent fasting from reckless deprivation. Autophagy and starvation can look similar from the outside. Both involve not eating, but biologically they occupy completely different territory. Autophagy is controlled, targeted, and regenerative. Starvation is chaotic, indiscriminate, and destructive. One cleans the house, the other tears it down. And the line between them is real, measurable, and worth respecting.
The deeper benefits of fasting also tend to stay hidden behind the surface-level conversation about weight loss. And that's a genuine loss, because what fasting does beyond burning fat is almost incomprehensibly more significant. Regular activation of autophagy has been linked to slower cognitive decline, to reduced systemic inflammation, the same chronic low-grade inflammation that underlies heart disease, diabetes, depression, and dozens of other conditions, to improved emotional regulation. People who fast consistently often describe not just physical changes, but a psychological reset, a heightened sense of clarity, a quieting of mental noise, a deeper relationship with hunger and fullness that transforms their entire relationship with food. There's something almost profound about it. Your body carries within it, encoded at the cellular level, a repair system that evolution spent hundreds of millions of years perfecting. A system that runs on the simplest possible fuel, not eating. And yet modern life, with its constant food availability, perpetual snacking, and never-ending caloric flow, keeps that system permanently switched off. The cellular cleanup crew never gets called in. The waste accumulates, the damaged proteins pile up, the broken mitochondria persist, and we wonder why energy fades, why the mind slows, why the body ages faster than it should.
Fasting isn't a trend. It's not a diet. It's the restoration of a biological rhythm that your cells have been waiting for, sometimes for years. And fasting isn't the only door into this state. Research has revealed that other lifestyle inputs can activate the same cellular pathways. High-intensity exercise temporarily depletes glycogen and creates a fasting-like metabolic environment that nudges autophagy into action. Cold exposure activates stress response pathways that overlap with autophagic signaling. Certain plant compounds, the polyphenols found in green tea, turmeric, berries, and red wine, activate AMPK, the same master energy sensor that fasting turns on. Deep, consistent sleep gives the body uninterrupted hours to run cellular maintenance without the interference of digestion and metabolic activity. Even moderate calorie restriction, practiced consistently over time, can sustain mild autophagic activity as a background process. None of these replicate the full depth of an extended fast, but they all speak to the same underlying truth. Your body is always looking for an opportunity to repair, and your lifestyle either opens that door or keeps it closed.
The consensus that has emerged from decades of fasting research is this: meaningful autophagy begins around the 12 to 16-hour mark. It deepens through 24 hours. It peaks in the 36-hour range. And beyond that window, for most people, the balance of benefit to risk begins to shift, and medical guidance becomes essential. Short daily fasting windows, the kind where you compress your eating into 8 hours and fast for 16, keep autophagy regularly engaged at a maintenance level. Occasional one-day fasts push the process deeper, offering a more significant renewal signal. And for those who are metabolically healthy and experienced, a carefully managed 36-hour fast represents what some researchers call the full autophagic reboot, the deepest safe window of cellular renovation available without clinical oversight. But the real secret isn't in the duration, it's in the consistency. Autophagy isn't a one-time event that you trigger occasionally and forget about. It's a rhythm, a pulse. The more regularly your body experiences this cycle of feeding and fasting, the more efficiently it runs the repair process. The cleanup crews get faster, the recycling systems get sharper. The body learns to maintain itself more effectively over time because it's been given the space, regularly and repeatedly, to actually do the work it was designed to do.
So the next time hunger arrives, not the boredom hunger, not the habitual snack hunger, but the real, honest signal that your body is running on its reserves, consider this, that hunger isn't a problem to be solved immediately. It might be a doorway, a biological invitation to let your cells do something extraordinary, something they've been doing for hundreds of millions of years, long before we had kitchens and grocery stores and snack drawers. You're not depriving yourself. You're giving your body the oldest, most powerful gift it knows how to receive, the gift of time. Time to clean, time to repair, time to rebuild from the inside out. And that might just be the most important thing you ever do for your health.